Right, okay, so first I'm going to tell you some things about MIDI. MIDI is exciting and wonderful. Oh, by the way, because of the video recording setup, I'm doing this whole thing without access to my notes, so I may at some points during the presentation not know what a slide is about. So bear with me. So anyway, MIDI is for musical instruments, and it allows you to send information to a computer from a musical instrument and vice versa. Right? That's MIDI. That's why it says MIDI. MIDI was invented in 1983 as a standardized interface. It is available pretty much everywhere in the world of music. You can get MIDI on a guitar, MIDI on drums. I have that. MIDI keyboards, of course, MIDI lighting systems. It's in your computer. It's in your iPad. Oh, is this a video? I think this is just a picture. I don't know. We'll find out. Right? But this is actually something that really happened, right? I have some kind of, I connected Ruby to my iPad via MIDI. It was magical. Okay, I guess it was a picture. This is a blog post about how to do that. MIDI's on your phone. Yeah. Notes are actually really handy. This is exciting. This is a synthesizer, which also has MIDI, drum kit that has MIDI, Arduinos. You can get an Arduino with MIDI. And this is Reason, which is a type of, it's like a whole set of software synthesizers and drum machines and whatnot that all have MIDI, right? And yes, you can use it to light up stages and power lighting systems. And even this is a sculpture/musical instrument from Burning Man a couple years ago, and I feel entitled to put it in my presentation because I sent them $10 on Kickstarter. So I made this happen. But in addition to being a sculpture and musical instrument powered by MIDI, it is also a flamethrower powered by MIDI, which is pretty cool, right? It is a ubiquitous protocol for lighting systems, music, and flame. Okay, I have no idea why this is in the presentation, and I'm not supposed to move around a lot for the video recording. I'm going to move over there. Here I am. This is this fantastic video of some weird performance in Prague, which is powered by MIDI. And this is a keytar, right? That wonderful, this is the whole reason the 80s existed, was to bring us the keytar. And this woman is holding a lamp. And they did this really weird performance, which consisted of her bringing all these lamps onto this table. And by the end, it was filled with lamps. And he would play music, and it would cause different lamps to light up. And it was like, this awesome sort of like synth pop video meets Antiques Roadshow. And but the whole thing, for whatever reason it existed, was powered by MIDI. So I'm going to come back over here. So yeah, so that was cool. MIDI. Oh, MIDI is kind of like HTTP. It's kind of like the HTTP of entertainment devices. It is this. It is everywhere. It is ubiquitous. It is very simple. It is a lightweight, minimal protocol. As you know, also a virtue that, or a trio of virtues that JSON has. So MIDI is kind of like JSON, but with flamethrowers. That was a cool fade in. And another cool fade in. So yeah, in the same way that you might want to. Okay, so just so you know, this presentation is supposed to go lightning fast with the assistance of the notes. Anyway, today, like if most of the people in this room, web developers, if we were putting together a way to control a flamethrower with a computer, we might think HTTP and JSON first. Yeah, I don't know. There's like some funny story about fire here. And then I get back to MIDI, which is everywhere and simple and minimal. and it's useful. Anyway. Yeah, thank you. Anyway, this is actually where content comes in. Justin Latimer node-midi. This is how you get MIDI working with JavaScript. Although, since I discovered this, they've actually got MIDI working through your browser. And I don't understand why or how. Like, you connect your browser to a synthesizer. I don't get it, but it works. But this I do get, so that's what I'm going to tell you about. Node-midi. So if you don't use Node, it's really easy. If you're on a Mac, you get Homebrew, you do brew install Node. You get NPM, which is like, a good thing. And then you do NPM install MIDI, and you have it, and hooray. And you also do NPM install CoffeeScript, because this is going to be in CoffeeScript. So this is what it looks like. I'm going to go over here, right, when you get started, right? You load up CoffeeScript, you do MIDI equals require MIDI, and you get this weird return value. And the reason that you get this return value that is almost completely opaque and tells you nothing is because it's a C binding, right? So it's just going to tell you that I have access to MIDI through C. And, that's all Node knows, so that's all it's saying, right? So then what you want to do is you go output equals new MIDI output, output get port count. So the concept there is here's your computer, here's something connectable via MIDI, and in order to connect them, you need a port through which, to connect them. So get the port count. You have one port. It's called IAC driver bus 1. This is just what Apple calls its default port. So you say output open port 0, and you now have that port open, and you do a send message, and it makes a noise, which you'll, for the moment, have to take my word for. But you'll actually hear noises soon. So, I could have just shown you this slide. So all this stuff that I just told you is true. Audio MIDI setup is what you use to make sure it works. Sometimes you gotta tweak the settings. And if you're having trouble, there's an app for OS X called MIDI Monitor, which will show you all the messages going through your system, all the ports, and you can track things down that way. So, you might have some synthesizers, and if you did, you would get a bunch more ports, right? So these are actual synthesizers on my desk, and here they all are. Like this is one, this is one, this is one. And sorry, camera guy. If you do this list, this is what you get. It's like all these synthesizers are registered as their own port, right? And that's what this graphic illustrates, right? Each of these things corresponds to one of those things. So I'm just going to skip. Oh, no, wait, this is important. OK, so you've got this output send message part. OK, and it sends these numbers, 146, 38, and 127, right? So 146 is the message number, 38 is the note number, and 127 is the velocity. So this is a chart of the note numbers. I can zoom in a second. Right? You got 146. That's note on for channel 3. Right? Right there, 146. And then the note number, that's, down here on the, can you see my mouse? Cool. This, I think, is probably note 36, going all the way up. Sometimes they start, where's the mouse go? Sometimes they start at 60, but basically each one of those keys has a number, note number, right? Makes sense. Each one of these drum slots has a note number, which will become relevant later. So then you've got this concept of velocity, right? So it's 127 here. It can be 0 to 127. Everything in MIDI is 0 to 127. They just love that number. I don't know. So here's the keyboard. So then you've got this concept of velocity. Like, why is there velocity? OK, so velocity actually means volume. And the idea was, when they created it in the 80s, OK, when you hit a piano key, right, if you hit it slowly, you get a soft sound. And if you hit it fast, you get a loud sound. So we'll actually model that so that you can make a perfect computer simulation of a piano, and that's what the future holds for synthesizers. And they were completely wrong, right? So instead, you look at velocity and you just remember that it means volume because they both start with the letter V, and you try not to think about it. So yeah. Also, you have note off, right? You have to send a note off message when a note is done, and that also takes a velocity of 0 to 127, right? Presumably because you need to be able to communicate a spectrum of offness. I don't know, but here's a picture of a fire. There's more fire, more koalas. I love koalas. They're great. So here's a drum machine, and here's code which emulates a drum machine. Here's the code converted to JavaScript. Here are the two versions. The top one is the JavaScript version. The bottom one is the CoffeeScript version. So I'll just tell you what this code does. Okay, this creates a class that has a note number and an interval, which when you're trying to do a rhythm of playing, you're going to have a cycle, right? And the interval is the length of the cycle, right? So 125, I think it means like 125 milliseconds, right? So it's if you're having like a hi-hat, right? It was like it would be like that. It would be like with the 125 milliseconds in between. And if you wanted to make it faster, you make it a smaller number for the interval. And if you want it to be slower, you make it a bigger number for the interval. So then you've got this play method, which sends the message 146, which is note on, and then the note number, which is any number from 0 to 127, of course, and then it just sends maximum velocity. And then you've got this play steps thing where it's got a list of steps, and for each one of them, it plays the drums. Which, I'll just show it to you because this is a bit chaotic. So here is the drum version. Okay. So the way this works, if I just open that up here, it requires some objects that I'm not going to show you, but they're basically what I showed you already, the drum and the loop player. Over here, you set, you get an output thing, which is through node-midi, you get an output manager available, right? Then you open port 0, and you assign that output thing to the drum, because the drum is going to send the message directly to it. Does anyone know the key combination that will invert a screen? It might be easier to read.
Just set syntax off and it'll be fine.
Yeah. No, that's all right.
Syntax equals off.
Yeah, okay. Hold on. Okay, so then you set the interval, right? And then these drum things, they basically always have the same MIDI channel, and they have different note numbers. So 45 and 37 and 36 are the note numbers. And that corresponds to this thing here, where this is 36, and this is 37, and all the way over here is 45, right? And if you listen to the drums when they play, you'll hear that it only uses those 3 drums. Right? Okay. So then there's also, these are just notes for GarageBand. I'm going to take them out just to make it simpler. Then you have this quasi-musical notation here. Okay, so the way to understand this the best is this is a ASCII version of a drum machine. Okay? And what I mean by that is, I'm going to go over there, right? This, now I'm here, right? This drum machine thing, right, is actually a way to view a two-dimensional matrix, an array of arrays. But this design is actually based on the designs that hardware manufacturers developed in the 1970s. Okay? So instead of viewing the two-dimensional matrix, right, as like a whole bunch of arrays, you have this right here, which is the array viewer, right? And then each one of these is a drum. So I'm going back over here, right? If I'm on this little select button, it's going to show me the array that corresponds to this drum. And each one of these arrays has 16 slots, right? And it's either going to be on or off. And then if I go to this drum, right, it's a different pattern of on and off, right? So this is actually a different beat because the beat that you were hearing before was in is in code, and this is just in the drum machine, right? But what you can see is that this, I tell you what, I'm just going to put this on here. I don't know if you'll be able to see it, but there's a little red dot that goes over the array. Can you see them? So it just, as it goes over the space, it plays the sound if the space is set on, right? So that's what this is here in the code, right? This one is 16, and it says the shaker is always on, right? So shaker is drum 45, which is this sound over here, right? And then the snare, right, it only plays twice in the loop because the dot only appears twice. And then the kick, right, it appears at the start of the loop and it goes kick, snare, kick, 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 snare, right? You guys all see that, okay? So first I just put it here in a readable format, and then I translate that into a series of arrays right here, right? So this is the shaker, and it's 16 dots. So you've got a 16-slot array with 16 ones, right? This is the snare that plays at the beginning of the second 4 and the beginning of the fourth 4. So here you have an empty 4, play the snare, and then 3 more, an empty 4, and then play the snare at the beginning of the fourth set, right? And then the same thing happens with the kick, right? So it's this same way of describing drum rhythms, transcribed to ASCII and then transcribed to code, right? And then you just have this loop player that plays the loop. So, and then you get that. Whoops. Huh. Then, yeah, okay. That was weird. Now I'm going to show you something else, which is a baseline version. And what I did to make the baseline version, it's basically the same code, except for 2 things, right? The first is that I added in some baselines, right? And these are just notes like 45 and 48. And again, the MIDI number just corresponds to a key on the keyboard, right? So the note makes a particular sound, right? But there's also this baseline equals true thing going on here. So what that is that in here, I think, yeah, it's got this play, okay, it defaults to baseline false, but it has a baseline method for playing bass, and the only difference is, here's play drums, right? They each loop through all the steps, right? And then this one just does a set timeout for on to play the drum, and this does a set timeout both for on and for off. And if you're familiar with set timeout, right, that's just do something after a timeout. So, you know, what you're doing is you're playing on or off for on and off messages in MIDI. So, you know, and it stays true to the 1980s roots of MIDI itself with this kind of like disco punk thing. Right? All right, so now I'm going to see what I can do with sort of wading my way through these slides. But I'll have to ask for your patience again. So here's some code. There's some more code. Here's nothing. Here's some more code. Here's this thing that I was just showing you where these they correlate. More code. Oh, Jasmine Node. Jasmine Node's great. I did specs for this in Jasmine Node. And I used sign-on. This is a spec. Signon.stub, because I also used Sign-on's fake timers. And the good news is that you might think, wow, how do you spec a drum machine? That's weird. It's actually really easy. You just set a fake timer and say that, you know, at this time, a message should be sent. Boom, you're good. However, with Sign-on's fake timers and Jasmine Node, there was, at the time that I wrote this, and might still be, a conflict which caused the specs to say that they had run in negative, like, 45 years. like a very, very large number of seconds, and I actually did the math, and they said that the specs had run 45 years before I ran them. So the fake timers might not be flawless.
Not quite the 80s, but close.
Not quite the 80s, right? Yeah, in that neighborhood, right? Yeah. So then there's all this stuff: use fake timers, play steps. Expect things to be truthy, and they are, and that's all fun. Oh, and if you want to use MIDI with your computer, right? You can't. How do I say this? It's not just that you can send MIDI out, right? You can also receive MIDI in. And if you don't have any hardware to receive MIDI in from, this is a cheap app that allows your trackpad to send you MIDI. And this is a free app that allows your trackpad to send you MIDI. And this is where I was going to demo something really cool that I didn't bring the machinery for. So you'll just have to believe me that, or not, that maybe it really was cool. There's a koala. You know what? Don't pay any attention to the fact that I didn't bring the hardware. Just look at the koala. It's upside down. No, I actually have a video of it. Okay. Let me see. Here it is on YouTube.
I'm going to control this CSS3 animation
he's ruining the
with
surprise.
this synthesizer.
He's going to control
Zero,
that CSS3 animation with that synthesizer.
Really
That's what he's doing.
really
That's me.
slow.
Spoilers. And
fast,
what you can see
moves
is that the
fast.
guy moves fast. Oh, wait, hold on. Let me just back it up. Okay,
really long
like when I
speed,
move that
moves
knob,
really
it changes
slow.
the speed of the dude.
Set it to
Right?
fast.
There he's
moves
walking fast. You can... God, that's really not... There we go.
Zero,
Okay.
stops entirely.
Yeah, you can even, if you
Set
take
it
the
to
speed
really
all the way
low
down to
speed,
zero, he
moves
goes
really
completely
slow.
still. Okay.
Set it to fast.
So what that is
he moves
modulating
fast.
is a CSS property called animation duration, right? And I've got more slides about that. So that'll be an interesting adventure. What does the future hold? It holds koalas. Oh, that's cool. The type's upside down too. Okay. So that thing that I just showed you is this CSS3 walking man animation. Have people seen this before? No? Apparently not. Okay. Yeah, I see someone nodding. Great. So it is an animation of a walking man done in CSS3. Okay? And what I did is I took Socket.io, which have people seen Socket.io before? Yeah. Okay, wonderful. Okay, so Socket.io is this thing that you know about. Okay, so I'm going to hop over there. Right? Here's a Socket.io app. This is a server in Node.js, and it's basically the Socket.io hello world. But it has a little line added to deliver static files for the JavaScript and CSS in the CSS3 walking man, right? And then it also has this, input equals new require MIDI input, right? So that is, big shock, the way that you get your MIDI input. And it does input open port, right? And if you'll notice down here, this is the sort of standard loop of Socket.io sending messages to the browser. Anytime it gets a MIDI message from the input, it sends part of that message like it's an array with 3 pieces, right? And it sends the third piece to the browser, right? And what that third piece is, when you're moving the knob, right, you're going to get 3 pieces of information, and one of them is the value of the knob, right? And that's the third piece of information. So you're sending that down to the browser, right? So I will go back over here. And what I did, okay, this is all this stuff that I told you, whatever. Here it is, okay? So it gets this data, and the data is going to be from 0 to 127, right? So it multiplies it by 40, which I think maybe adds up to 5,000. I don't know. I think the math in this is actually suspect, but it does math, right? And the reason it does math is because what it's doing here is it's trying to come up with a value for animation duration, right? So that's the CSS3 property, which says how long is the animation cycle lasting for. So if your animation cycle is 0, there is no animation. And that's what you get when the man is just like this, right? Because the animation duration is 0, he remains completely still, right? If you take it all the way to 5,000, the animation duration is 5 seconds, and he's walking really slow, right? But MIDI will send you a number between 0 and 127, right? So obviously you need to multiply that by something to expand the range, because the range from 0 to 127 milliseconds is very, very small. It's very fast, right? And that's not something that a human being can probably even perceive, right? So you multiply it in order to create like a time frame, so you can go from 0, where it's still, to, the first couple hundred milliseconds where it's incredibly fast, and the walking man looks like this, right? Except blurrier. And then, if you take it all the way out, you get 5,000, and it's this super slow walking man. And then all it does after this is it sets the WebKit animation duration to that speed, that number of milliseconds. Unfortunately, it should then cascade through, the cascade, right? Because it's well-written CSS, it's well-written HTML. It should just cascade right down. But apparently, I don't know, I think it was a browser bug, it didn't cascade animation duration. So when I first got this working, I would get like the core animation of the guy's like torso would change speeds, and the arm would continue at like the regular speed, and it would just look ridiculous, right? So it just manually sets all these, because I was like not clever enough to make it all fancy and functional in 3 lines. But whatever. Anyway, so then here's socket.io. There's some code that I was just talking about. 0 to 127, you'll remember. Which, see, it does add up to 5,000. Hooray! Math. Here is a blank enigmatic slide. I don't know what's going to happen next. Oh, this is this other thing I also told you about. Oh, and a laser. This is so cool. This is some more machinery I didn't bring either. What you can do with this, people have actually gotten this to work. I just told you all about MIDI, right? But there's another format that you can use called DMX, which is really easy to use, says the guy who didn't get it working. And it powers lasers and strobe lights and fog machines and things like that. And there is a CoffeeScript library for it. And I spoke to the guy who wrote it, and he wrote it for a party in like Finland where they had all kinds of lasers and shit controlled by CoffeeScript. So go Finland, Anyway, I have a website called singrobots.com. It has free videos and videos for sale about this stuff. Frankly, most of them are about as coherent as this presentation. So, I don't know. That's not the best sales pitch ever, but it's the truth. Anyway, this is me. That's my name. Thank you very much. Any questions?
Yeah. I just wanted to add one quick thing. The core nano control is such a transformative device. You talked about synthesizers a lot. Synthesizers come with a bunch of knobs on them, but they're kind of an investment. There's a device called the Core Nano Control, which is a USB device about this big. It fits in your bag. It's got like 4 knobs and 8 sliders. It plugs right into your computer, and you can read it in this way. And I mean, there's a certain class of problems where, like David put up 3 sliders on the screen. You shouldn't have to put those up on the screen, right? Buy this thing, hook it up to a stream, right? And all of a sudden, with a simple device, probably costs $40, right?
Yeah,
it's a MIDI device. One that is probably designed for making music. I can't make music, but I use it for software development and Node all the time, and it's a great device to have.
I actually, that's how the first time I give this presentation before and demoed the walking guy with that very device. But I lent it to somebody, actually. And didn't get it back, Yeah. I don't know what's up with that, but okay. Yeah. But yeah, they're like $40, and they are, they've got, what, like 8 sliders, 8 knobs,
6 knobs,
transport buttons.
There's another one with a
Yeah.
touchpad. There's another one with a
Yeah.
keyboard if you want to play piano.
Right. But the touchpad is the way to go, right? I mean, that's fun. Yeah. Other questions? Something? Anything?
What's up? With that fixed interval and array notation for setting the playing different instruments, did you ever find a way of introducing drifts or errors into where the notes fall?
Oh yeah, I mean what you have is very, very precise control. I mean to the millisecond, right? You're saying at this millisecond play this note, right? And the first time I started doing this, I did it in Ruby, and I got drift for free. That was cool, right? But now the advantage with Node is that the timing that you get is actually quite precise. But what you would do is, you've got this code here, right? Actually, it would be in here, loop player, right? And okay, I don't know where it is, but it's in there somewhere. Was it? No, here we go, like this, right? So set timeout on, step times interval, set timeout off, right? And this, I'm just going to turn off the syntax again to make it easier to read, right? This right here, step times interval, you're actually sending a number, and you're just saying it's this number of milliseconds. So you could easily, then have an additional thing, which is maybe you have a humanizer, right? Or a drift function, right? Like that. And that would be very, very easy to add to it, actually. Although I didn't, because I was all about the robotic 80s sound, but More questions? Yeah, nothing? Nothing? No? Yeah, okay, thank you.